Hi and welcome to Cherry Pie Math. This video is going to introduce what an exponent is and the different kinds of exponents you might come across. So first I want you to take a look at this graph. This is a super common graph in the real world and it represents what we call exponential growth. So I just want you to pause the video and think about what you notice about the shape, like the steepness of the curve or where it is on the x and y axes. I'm not going to go into depth about the meanings behind this graph, but visually seeing a concept before getting into the algebra just helps things click a little bit. So just pause the video, take a look at the graph so that when we talk about exponents, you're able to see those patterns later. Okay, so let's get into what actually are exponents and where they come from. So exponents are a way to show how many times we multiply a base by itself. So on this slide, you can see here a to the power of b. That's how you would read it, the base to the power of the exponent. So like a to the bth power or a to the power of b. So that would mean that you multiply the base a by itself b amount of times. So for example, if I had 2 to the third power or 2 cubed, because when you have a power of 3, you call it cubed as well. It's like the slang name. So you would do 2 times 2 times 2, 3 times. So let's do some examples. Oh, look, I had 2 to the power of 3 after all. The base is 2, the exponent is 3 like we had before. And if I was to expand it, I'd write 2 times 2 times 2. Not 2 times 3. That's a really common mistake that I've seen a lot of students do. It's super tempting to want to do 2 times 3, but it's not. It's an exponent, and so only the base is going to be written when you write the expansion. It'll be 2 times 2 times 2. You actually never even see the number 3. It's just going to be 2 times 2 times 2. So simplified, this would be 8 because you would, multiply it out. Then we have 5 squared or 5 to the power of 2. The base is 5. The exponent is 2. Expanded would be 5 times 5, and simplified would be 25, because 5 times 5 is 25. So let's do it one more time. 3 to the power of 4 has a base of 3, an exponent of 4, and an expansion of 3 times 3 times 3 times 3. And if you multiply that out, simplified, it would be 81. So quickly going back to the initial graph we looked at, exponential growth gets really big really fast. So it kind of starts out flat, especially when you have like fractions and negatives. But then as you can see from just the examples that we had, that steepness or the amount it increases gets really big all at once. Like with 3 to the 4th, we started at 3, but then all of a sudden within 4 exponents, we ended up at 81. Anyway, back to where we were. To simplify an exponential expression with a numerical base means to multiply it out to a single number. So like how 3 to the 4th what became 81. That's what it means to simplify, is basically you, instead of having 3 to the 4th power, you just figure out what that would be in your calculator. There are some special cases because exponents don't just need to be positive integers. We're not always going to have like 3 to the power of 4 to the power of 3, right? It can be, there's a ton of different numbers out there and they don't always have to be positive integers. So I'm not going to talk about fraction exponents because that's like a whole other thing, but we are going to be talking about some other special cases. Special case number 1, if the exponent is 0, then it simplifies to 1. Always. Well, kind of, except if the base is 0, and I'll talk about that in a second. So for example, 105 to the 0 power, 1. 4 to the 0, 1. 53.2 to the 0 power, 1. Pi to the 0 power, 1. Any crazy number you can possibly think of, 1. 0 is the coolest exponent in my opinion. Okay, special case number 2. If the exponent is 1, then it simplifies to itself. If we use the same numbers as before, 105 to the first power would be 105. 4 to the 1 would be 4. 53.2 to the first power would be 53.2, and pi to the 1 would be pi. The reason for these comes from the definition of exponents. So let's start with 2 to the 5th. That's 2 times itself 5 times, which comes out to be 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 squared is 4. Let's pause here and look as we go downwards. So instead of multiplying by 2 like we would if we added another exponent, like if we were going upwards, when we go downwards, we are dividing by 2. So that follows the pattern as we go down to 2 to the first. So since we were at 4, when we had 2 squared, 4 to the first power would be 4 divided by 2, or just 2. And this is going to happen with any base you use. You can also think of it as it appearing just once, not needing to be multiplied by anything else. But we can keep dividing. So if we keep dividing, any number divided by itself is just 1. So that's why any number to the 0 power is 1. And also why why 0 is such a weird case. Like 0 to the 0 power wouldn't necessarily just be 1, because you can't divide by 0. But we can keep this going to the negative numbers. So yes, we have 2 to the 0, which was 1. 1 divided by 2 is 1/2, which is now 2 to the negative 1. And if we divide that by 2 again, we get 1/4, and then 1/8, and then 1/16, and then 1/32. And if you look at the denominators, they actually match what we got for the positive integer exponents. They are just in a fraction now, which brings us to our third special case. If the exponent is negative, then we put it in the denominator, simplify it, and put a 1 on the top. So for example, 2 to the negative 3 is 1 over 2 to the third, or 1/8. This would just be 1/4 to the 1 power, or just 1/4. 3 to the negative 4 would be 1 over 3 to the 4th, or 1 over 81. And 8 to the negative 2 would just be 1 over 8 to the 2, or 1 over 64. It really is the same as the positive integer exponents. It's just on the bottom. So you're going to solve it as if it was positive and then just throw a 1 on the top. Be careful though. Negatives can be tricky. If we have negatives, then they don't really follow necessarily the same rules as like a negative and a negative cancel out. So if you have a negative, you have to remember PEMDAS, because multiplication comes after the exponent, but parentheses come before exponents too. And you need to remember that a negative times a negative becomes positive. So let's look at these first two. The first one doesn't have a parenthesis, so technically we are going to do exponents first and then multiply it by the negative. So we're going to do 2 to the 4th and then multiply it by the negative, since multiplication comes after exponents. So you would have 2 times 2 times 2 times 2, which is 16. And then you would be multiplying that negative, since that's not that negative isn't attached to that 2. It's multiplied on the outside. So it becomes negative 16. But in the other one, since it is in parentheses, we are applying the negative 2, and we're the exponent to the negative 2 in its entirety. So it ends up being negative 2 times negative 2 times negative 2 times negative 2. And the negatives cancel out for the first 2 and the last 2. So we end up with positive 16 instead. So that parentheses really makes a big difference. Make sure you're paying attention to if there's parentheses or not. Not just if you're solving it, but also if you're putting it into a calculator, because the calculator is going to follow PEMDAS. Another common mistake I'll see with negatives is when you have a negative base and a negative exponent. They do not cancel each other out, since the negative exponent isn't really a negative. It's more like a division symbol, and it's going to be transforming into a fraction. However, in this case, since the exponent is odd, the negative doesn't cancel out, and we end up with the same answer for both cases, with parentheses, without parentheses. So all in all, just use parentheses, especially when you're in doubt. Just use them. I like parentheses. They never hurt anybody. Okay, so some things to remember. Exponents mean you multiply the base by itself that many times. Negative exponents do not make it negative. It makes it a fraction. Be wary of negatives and parentheses. These are going to catch a lot of students. Don't be one of them. And anything with an exponent of 0 simplifies to 1, except maybe 0, since you can't divide by 0. Anyway, I hope that helps, and good luck.